Hello everyone. Today I am here with you all with a new topic of mathematics, that is surface area and volume. We all know about what area is, what is surface area. In our previous classes we have studied that whenever we are talking about a two-dimensional figure, that means whenever we are talking about a plane figure, we are considering the term area. But whenever we are talking about a three-dimensional figure, that is your solid figures, we are using the term surface area. So area is basically the space occupied by the plane figure. Like your square is there, rectangle is there. So for all these type of figures, we are using the term area. But whenever we are talking about a solid figure, like your cube is there, cuboid is there, and your cylinder or cone, all these type of figures, we are using the term surface area. Why we are using the term surface area over here? Like what all the faces are there, what all the surfaces are there in that particular figure. If we are going to add the areas of all these surfaces, then we are getting the surface area. So for three-dimensional figures, we are using the term surface area, and for two-dimensional figure, we are using the term area. In the last class, that is your in ninth standard, we have studied all the surface areas and volumes of solid figures. Now just have a recap over it. Total surface area of cuboid. So cuboid, how it looks like if we are going to take all the faces as your rectangles. The figure which we are getting is your cuboid. Over here, this is your L, if this is the length, if this is the width, and this is the height. So total surface area of cuboid, that means total area of all the six faces will be 2LB plus BH plus LH. This will be the total surface area of cuboid. If we are going to ignore the lower or the upper, these two faces, if we are ignoring, we are taking only the four faces, then we are getting the lateral surface area, and the lateral surface area is given by 2HL plus B. This is your lateral surface area of the cuboid. Total surface area of cube, that means cube is when all the faces are equal, all your length, width and height all are equal, then we say it to be a cube. And the total surface area of cube is 6a square, where the side of the cube is a, means length is even a, width is even a, and height is even a. If this is the case, total surface area of cube is 6a square, and the lateral surface area of the cube will be 4a square, because we are ignoring the top and the bottommost surfaces. So we are taking only the four surfaces into consideration. So lateral surface area will be 4a square. Now if we are going to take the curved surface area of cylinder, so whenever we are talking about cylinder, it looks like this only. So cylinder curved surface area means we are considering only this much of part. We are not taking this and we are not taking this. If we are not taking the upper and the lower portion, then this is your curved surface area. So curved surface area of a cylinder is 2 pi r h, where h is the height of the cylinder and r is the radius of the cylinder. And if we are going to take the uppermost and the lowermost areas also, which is a circle, so area of circle is pi r square here also, so it will become 2 pi r h plus 2 pi r square, that will be 2 pi r plus h will be the total surface area of the cylinder. Now if we are going to take the curved surface area of cone, curved surface area, again we are not taking the bottommost portion, we are just considering this portion, we are not taking this portion. So if this is the area, so curved surface area will be pi r l. Here r is the radius of the cone and this is the height, this is h, height of the cone, this is radius of the cone, and this slant height is denoted by L. So we are taking the slant height over here, pi r L. If we are knowing the r and if we are having the value of h even, by Pythagoras theorem we can find the value of L. So L will be, how we can find it out? It is a right angle triangle. So in a right angle triangle, hypotenuse square will be base square plus perpendicular square. So value of L will be r square plus h square, square root of that. So L will be square root of R square plus H square. This is how we can find the slant height of a cone. So this is the curved surface area. When we will be adding this circular area also, it will give us total surface area of cone. That will be pi RL plus pi R square, that is pi R in bracket R plus L. This will be the total surface area of the cone. Now surface area of a sphere. So in a sphere, it is not your curved surface area, it is total surface area only. It is not divided into curved surface area or the total surface area. Whenever we are talking about sphere, it is always the total surface area only, and it is your 4 pi R square, where R is the radius of the sphere. Now curved surface area of a hemisphere. Curved surface area of hemisphere is half of your total surface area of the sphere, that is your 2 pi R square. Again, we are not considering the bottommost your area, that is of circle, in your curved surface area of the sphere, hemisphere. Now if we will add that also, it will become your total surface area of the hemisphere, that will be 2 pi R square plus pi R square, that will give us 3 pi R square, will be the total surface area of the hemisphere. Now we will be talking about volumes. So volume of cuboid will be, if its L length is L, width is B, and height is H, so it will be LBH. This is the volume of the cuboid or the capacity of the cuboid. Volume of cube will be, if the side is A, so it will be side cube, will be the volume of cube. If we are talking about volume of cylinder, it will be pi R square H, where R is the radius of the cylinder and H is the height of the cylinder. If we are talking about the volume of cone, it is 1/3 of the volume of the cylinder, that is 1/3 pi R square H. Volume of sphere is 4/3 pi R cube. So wheresoever R is coming, it is radius of that particular figure only. Like over here we are saying volume of a sphere 4/3 pi R cube. So R is the radius of the sphere. For the cone, it will be radius of the cone only, means base of the cone. So wheresoever R we are considering, it is radius only of that particular figure. Now volume of hemisphere will be half of the volume of the sphere, that is 2/3 pi R cube. So all these are the formulas of the surface area and volume of the solid figures that we have studied in class 9th also. So in class 10th, what we will be doing, we will be using all these formulas and we will be finding this your surface area and volume of the combination of solid figures. So whenever we are going in our day-to-day life, if we are going to see, so there are so many shapes are there which are combination of these solid figures. It is not individually sphere or individually it is a cube. It is a combination of two or more than two figures. So how to find out surface area and volume of these combination of figures, that we will be studying in this chapter. So suppose I am going to take an example. Suppose I have taken a cylinder. This is a cylinder and at the both sides we are having a hemisphere connected with it. It is not only cylinder, at both the ends we have added a hemisphere also. And if we have to find the surface area or the total surface area of this shape, means we can assume it as like this is a cylinder. Over here at the top we have taken a hemisphere. At the bottom even we have taken a hemisphere. Now what will be the total surface area of this combination of solids? Now see over here, if we are going to see this total surface area, means your surface area of this cylinder. In this we won't be considering this area, we won't be considering this area. That means we will be simply considering the curved surface area of the cylinder, because over here though we have taken a hemisphere, that means this part is hidden now. So over here we have taken a hemisphere, over here also we have taken a hemisphere. So we will be considering the curved surface area of the cylinder and curved surface area of this hemisphere and curved surface area of this hemisphere. Again, we won't be considering the total surface area of the hemisphere, because bottommost part of your hemisphere is again hidden. So whatsoever is visible, we will be considering that area. So it will be curved surface area of cylinder plus 2 times of curved surface area of hemisphere. What we are assuming over here कि whatsoever is the radius of the cylinder, the same is the radius of the hemisphere also, because it is just overlapping at the top of it. That means radius of the cylinder is equivalent to radius of the hemisphere. In this case, total surface area of the figure will be curved surface area of cylinder we have just now discussed. It is 2 pi r h. And curved surface area of hemisphere, just now we have seen it is your 2 pi r square, but because there are two hemispheres are there, so we will be taking plus 2 multiplied by 2 pi r square. That will give us the total surface area of the given solid. So this is how what we will be doing. We will be finding the total surface area of the combination of figures. So most of the time whatsoever happens is, whenever we are taking a combination of figures and we have to find the surface area, in most of the cases we are considering the curved surface area, because the bottommost portion, it is in most of the cases it is hidden. So in most of the cases we are using the curved surface area. It depends upon the question. We will be seeing the question, how the figure is, and accordingly we will interpret, or we will be analyzing that what we have to consider. But whenever we are talking about the volume, always we are taking the whole volume only. The combination, we won't be taking half volume, or we will be considering always the full volume only. That means if we have to consider the volume of this figure, it will be volume of the cylinder plus volume of this hemisphere plus volume of this hemisphere. That will give us the volume of this combination of solid figure. So that means it will be the volume of this cylinder is your pi r square h. Again, radius we have considered that it is same for cylinder also and for hemisphere also. And volume of hemisphere, just now we have seen, it is 2 upon 3 pi r cube. Either we will multiply it by 2, or again we can add 2 upon 3 pi r cube for the another hemisphere. So this is how we will be finding for surface area and volume for the combination of figures. Another example we could take is, suppose a cube is there, and at the top of it we have kept a hemisphere. Suppose I can see this is a cube, and at the top of it we have taken a hemisphere, and whatsoever the side of this cube is there, the same is the diameter of this hemisphere. This we have assumed that we have kept it over here, and its edges are just touching the edges of this cube. In that case, what will be the total surface area? So what we could do is, we can find the total surface area of the cube over here, and see here, this whatsoever the area of this bottommost, that means your this part, this circular part is there, it is hidden from the top, from the surface of the cube. This part is hidden. So what we will be doing is, we will be finding the total surface area of the cube, that is your 6a square. If the side is your a, side of the cube is a, then the total surface area will be 6a square. But we have to reduce this circular area from it, because it is not visible to us, it is hidden. So we will be subtracting minus pi r square. This part we have just ignored, and we have to add the curved surface area of this hemisphere, because this hemisphere is visible to us now. So we will be adding the curved surface area of the hemisphere, that is your plus 2 times of pi r square. That is your curved surface area of the hemisphere. So for finding these type of questions, we have to see what is the hidden part, what is visible, and accordingly we will be analyzing, we will be finding your curved surface area and the total surface area we will be finding of the figure. So here 6a square, what we have taken is the side of your cube. It is equivalent to 2 times of radius. From here we can find the radius also, radius of the hemisphere also, because whatsoever the side of the cube was, it is equivalent to the diameter of your hemisphere. So radius of the hemisphere will be half of the side of the cube. This is how we can find your curved surface area or the total surface area of the given figure. But when we are talking about the volume, it will be combination of these two. That means volume of the your cube, that is your a cube, and volume of your hemisphere, that is 2 upon 3 pi r cube. This will be the volume of the given figure. In this case, whenever we are finding the volume, we will be taking the total volumes, and whenever we have to find the surface area, we have to check which all areas is to be considered. This is how we will be solving the questions. This type of concepts we will be using. Means we have to check the figure, we have to check the solid shape, and then only we have to analyze that what area is to be considered. So what we had learned till now is, if any combination of solid is given to us, what we will be doing is, first we will break down into the constituent figures. Means the figure is made up of which all figures we will be finding it, and accordingly we will be applying the formulas, and we will be finding the required thing, whether it is volume or the surface area. Now let's see how we can apply this concept in solving the questions. So first question we have taken is, volume of largest right circular cone that can be cut out from a cube of age 4.2 centimeter is. So we have taken a cube and its age is given to us as 4.2 centimeter. Right circular cone means if this is your radius of the cone and this is the height of the cone, then this is making an angle of 90 degree. That means radius and height of the cone, if they are at preparing an angle of 90 degree, then we say such type of cone as right circular cone. So over here what we can see is that this is the age of the cone, that is 4.2 centimeter, and this is only the diameter of the cone also. So diameter of cone is given to us as 4.2 centimeter is the diameter of the cone, and if diameter of cone is 4.2 centimeter, we can say that the radius will be 4.2 divided by 2, that is 2.1 centimeter will be the radius of the cone. From here we can see that the height of the cone is even equivalent to the your side of the cube. So height of the cone will be height of cone, that is h, it is even equivalent to 4.2 centimeter, that is your side of the cube. Now for finding, we have to find the volume. So volume will be volume of the cone, we know that it is your 1 upon 3 pi r square h. Why we have taken it like this? Because it is only the possible largest right circular cone. If we will be using both the bottommost and topmost surfaces, whatsoever the cone will be formed, that will be the cone with the largest volume. So we have taken this condition. Now see over here, just now we have seen that this is the radius r, this is the height h. So we have to keep the values in this formula and we will be getting the volume of it. So it will be 1 upon 3. Value of pi, whenever it is not given, that take pi is equivalent to 3.14. Generally we take it as 22 by 7 only. Value of r, just now we have calculated, it is 2.1. So r square will be 2.1 into 2.1, and then it is your h, that is your 4.2. We can just remove the decimals and keep 10 in the denominators also, because everywhere in all the 3 digits your 1 decimal place is there. So we will be removing the decimals and 10 will come in the denominator. So this, if we will be solving it, 3 7 is 21, 7 7 cancelled. That means if we will multiply 22 into 21 into 42 over 1000, and because it is volume and the unit is centimeter, so answer will be in centimeter cube. So we will be solving it and we will come to know that what will be the volume of the cone. This is how we will be using the concepts. Let's see another questions. Now let's see another question. A wooden toy is in the form of a cone. So we have taken a cone mounted on a hemisphere, which is mounted on a hemisphere. So at the bottom it is hemisphere is there. At the top of it there is a cone which is mounted on the hemisphere with the same radius. That means radius of the cone and radius of the hemisphere is same. The diameter of the base of the conical portion, so this is the base of the conical portion, it is given to us as 6 centimeter. That means here this diameter is 6 centimeter given to us, and its height is 4 centimeter. And this height, this is the height, and it is your 4 centimeter given to us. Determine the volume of the toy. We have to find the volume of the toy. So just now we had discussed that whenever we have to find the volume of the combination of figures, we just sum up their volumes. So what the volume will be of this toy, it will be the volume of the hemisphere plus volume of the cone. So volume of the toy, we can find it out. volume of toy will be volume of hemisphere plus volume of cone. We know that the volume of hemisphere is given by volume of hemisphere. It is 2 upon 3 pi r cube. R for both the hemisphere and the cone, it is same, it is given to us. And volume of cone is given by 1 upon 3 pi r square h. Now if we are going to see, r will be the diameter of the base is given to us as 6 centimeter. If diameter is 6 centimeter, we can see that the radius will be half of diameter, that is it will be 3 centimeter for both your hemisphere also and for cone also. Now what h is? H is the height of the cone and h is given to us as 4 centimeter. So we are having the values of all the variables. Now we can find it out the volume of the toy. So volume of toy will be volume of hemisphere, that is your 2 upon 3 pi r cube, plus volume of cone, that is 1 upon 3 pi r square h. We know the r is same for both the two cases. So what we could do is 1 upon 3 is common for both, pi is even common for both, and r square is even common for both. So we have taken 1 upon 3 pi r square, we have taken common. Now what is remaining over here? 1 upon 3 taken common, pi taken common, r square taken common. So remaining will be 2 times of r here. And over here 1 upon 3 taken common, pi taken common, r square. So remaining will be h. So we have to solve it. So we'll be keeping the values. So it will be 1 upon 3. Value of pi we will be taking as 22 by 7. Value of r we know it is 3. So we will be multiplying it 3 into 3 because it is r square. So taken 3 2 times. Then in the bracket it will be 2 times of r, that is 3. 2 times of 3 plus h is your 4. Now we will be solving it further. This 3 can be cancelled. Remaining will be your 22 into 3, that is your 66 over 7. 2 multiplied by 3 will be 6. 6 plus 4 will be 10. So it will become 660 over 7. So if we will divide it, it will be 7 9 is 63. Then 3 30. 7 4 is 28. 2 remainder. So 7 2s are 14. Like that it will be centimeter cube. So this is how we can find the volume of a combination of figure. Simply we have to find for individuals, we need to find what the volume will be, and then we will be adding it for finding the volume of the combination of the solid figure. It must be clear that if it is given, it is just mounting over the one over the other, then the radius will be same for both the two figures. And it is given to you in the question also. So accordingly, we will decide what is to be taken. Till now, we have seen two examples of finding volume. Now let's see one of the example of finding surface area. A wooden article was made by scooping out a hemisphere from each end of a solid cylinder. It is a solid cylinder. From both the ends, scooping out of a hemisphere. From here also, scooped out one of the hemisphere. From here also, scooped out the hemisphere. Now, as shown in the figure, if the height of the cylinder is 10 centimeter, this is the cylinder and its height is given us as 10 centimeter. And this will be the radius. And the base radius is 3.5 centimeter. The base radius is given to us as 3.5 centimeter. This is the base radius given. Now find the total surface area of the article. Now first of all, we have to analyze that what all the surface area we are going to consider. We can see over here that for the cylinder we will be considering your curved surface area, because the topmost surface and the bottommost surface, it is not there. Hemisphere is scooped out of it. That's the reason we will be considering the curved surface area of the cylinder. Now if we are going to see the hemisphere also, so this part is visible to us. it is dotted, it is not visible, it is imaginary only. So this part is visible to us, and over here also this part is visible to us. That simply means we will be considering curved surface area of the hemisphere. We won't be considering the total surface area of the hemisphere because it is not covered from the top, right? It is only scooped over here. That's the reason we will be considering the curved surface area of the both the hemisphere and the curved surface area of the your cylinder for finding the curved surface area, total surface area of the this article. Now this total surface area of article, it will be curved surface area of cylinder plus 2 times of curved surface area. Instead of writing the curved surface area, I am writing CSA, curved surface area of hemisphere, because there were 2 hemisphere, so I have multiplied it by 2. Now we can see from the figure that radius of the hemisphere and radius of the cylinder both is same. So radius of hemisphere is your equivalent to radius of cylinder, that is your R, and it is your 3.5 centimeter. Height of the cylinder is given to us as height of cylinder is 10 centimeter. All this is given to us. Radius is given and height is given. Now the total surface area of article. Now curved surface area of cylinder, we know that curved surface area of cylinder, it is your 2 pi r h. If we are going to solve it, we will be getting 2. Pi value we will be taking as 22 by 7. Value of r is given to us as 3.5 and value of h is 10. So we will be keeping all these values. If we will remove the decimal, 10 will come in the denominator. These two 10 are cancelled. 7, 5 is 35. So it will become 220 because it is area. So unit will be centimeter square. Now we have to find the curved surface area of hemisphere. So curved surface area of 2 hemispheres we are taking. Directly we are multiplying it by 2. So it will be 2 multiplied by. Now we have to take the curved surface area of hemisphere. That is your 2 pi r square. So we can write it as 2 multiplied by 2 multiplied by, value of pi will be 22 by 7 and value of r is 3.5. So we have, because it is a square of r, so we have taken 3.5 into 3.5. When we will be removing the decimal, 10 will come in the denominator. Now 7, 5 is 35, 5 2s are 10, 2 cancelled. 5 7 is 35, 5 2s are 10, 2 cancelled. So remaining is your 22 multiplied by 7. 7 2 is 14, 1 carry over 15 centimeter square. So curved surface area of 2 hemisphere is 154 centimeter square. Curved surface area of cylinder is 220 centimeter square. And for finding the total surface area of the article, so your total surface area of article, instead of total surface area, we can write it as TSA of article is sum of these two, that is 220 plus 154, that will turn to 374 centimeter square. So this is what is required, total surface area of the wooden article. This is all for now. Hope it is clear to you how to find out the surface area and volume of the combination of figures. Practice more and more questions. Soon we'll be coming with a video on the questions which are generally asked in the board examination based on this chapter. If you have not yet subscribed my channel, please subscribe it. Soon we'll be coming with more and more videos on the chapters. Thank you.